Calculus student, in this video I'm going to talk about volume with a washer method with the assumption that you have already learned how to do the disk method. So extension of disk method is called washer method, and what that is if you are given a shape which is like not connected to the axis, like for example something like this is hanging up in the air and you are revolving around the axis, then you have to scoop out the volume in between. You have to take out this shape. So let's explain from these actual pictures here and understand the formula. So rotation, axis of rotation is very similar to with the disk method. Sometimes we rotate along the x-axis, sometimes we rotate along the y-axis. Now when we have a shape up in the air, we have to take out this volume, which is big radius square, the farthest one, small radius is the closest one. So very similar to top minus bottom, but we are squaring the volume. We are squaring, so pi r square minus pi r square. That's what we are subtracting the two volumes. Sometimes we do vertically, which is a revolving along the y-axis. And when we revolve along the y-axis, then we have a very similar big radius, small radius. Difference is everything is in terms of y. So curious is how this shape would look like if you are doing in terms of a y. Then you have something like this, the flat shape with a hollow inside. If you are doing in terms of x, if you are revolving this way, so think about you will have similar shape like this, very similar to the shower curtain ring. So same concept. It's just that we are subtracting the two volumes, subtracting the two volumes. Okay, so draw the picture. You have to show the big radius and small radius on the diagram, which helps a lot, Writing equations, you can keep r and r, but make sure you are not squaring. This is wrong. You are not subtracting radiuses, you are subtracting volume. You are subtracting volume. So why the name washer method? Washer method is because, like again I told you, the shape is hanging up in the air on the axis of rotation. Then again there is a hollow, looks like a washer. So that's why it's very popular name, washer. So we are going to look at some examples on here using washer method. So find the volume of the solid formed by revolving square root x and x square. So let's sketch the graph first, how square root x and x square look like. So square root, let's do it again, 1 and 1. So parabola goes up, square root goes down, and you can clearly see they both intersect at 1. Okay, so the region in between, top minus bottom, region in between, shade that with a pencil, and you are revolving along the axis x, about the x-axis, which means everything in terms of dx. So big radius minus small radius. Integration from 0 to 1. Pi, big radius square, pi, small radius square, subtracting two volumes. So this is just the initial setup. You are expected to show full equation as well. So if you want, you can factor out a pi and keep it right like that, but be careful, you are still squaring individually. This is a difference of square. This is a difference of square. As a calculus student, you should know that a minus b square is never a square minus b square. That's not true. That's not true. That's not true. So subtract square root x square is x, square square is x to the 4. And of course, I'm not going to explain the antiderivative techniques. You are expected to know how to do that. My purpose here is to only show you the setup. Curious part is how this would look like if you revolve around the x-axis. This is the shape. This question is straight from the textbook, and I took some pictures from the textbook to explain how this would look like. So there is nothing inside. 0 to 1, we revolve around the x-axis. This is the shape, and we took out hollow, and This is a washer method. So quick again, one more time. dy means everything in terms of y. Limits of integration y, formula y. Dx means slicing perpendicular to the x-axis, everything in terms of x. You always subtract two volumes, never subtract the two radiuses. So we are going to look at few more examples, and this is again repeated information again. Draw a picture, show the perpendicular big R, small r, and show the setup. This is, you are not subtracting two radiuses, you are subtracting two volume. Okay, so let's we have a few shapes. Volume of the solid formed by y equal to x. So sketch this. Y equal to x and x square. Very similar shape. The other side we did the other way. This is a parabola and this is the shape. Now we are going to rotate few different ways. So let's check here. Line y equal to 1. So I'm bringing that shape here and talking about the line y equal to 1. So this is my line y equal to 1 and I'm rotating here. Axis of rotation is a horizontal. Radiuses are perpendicular to the axis of rotation. So this is your big R, this is the small r. Getting an equation of the r is most important. You know that the whole thing is a 1. So 1 minus, take out this piece which is x square. Whole thing is 1 and I want only this blue color piece. So I have to take out this piece which is x. 1 minus x square, 1 minus x. Now everything else is same as this is your big R, this is your small r, pi r square minus pi r square. Set up 0 to 1 because we are doing everything in terms of x. Axis of rotation is and the radius are perpendicular to each other. Let's take a look at another example here. Line y equal to negative 5. Y equal to negative 5. So the same shape, but line is way below. So I'm going to explain here. Big radius and small radius. The distance extra 5 we are adding. This is a 5. So 5 plus line which is x. 5 plus parabola which is x square. Most students make a mistake. They write negative 5 plus x. That is not true. Negative 5 is just telling you axis of rotation is this line. So we have a long distance which is extra 5 and x, extra 5 and parabola. Everything else is still same, big R, small r. Make sure you have extra set of parentheses, square, square. You can evaluate using calculator. Make sure you bring down the pi. Most common mistake, student forget about pi. So we are doing two examples with axis of rotation as a line other than the x-axis. Now let's take a look at how do we rotate vertically. Okay, so vertical rotation is, let me clear and I just show you. This is my shape. Rotating this line which is negative 1. So how do you know you are doing in terms of x or y? Your line radius is perpendicular to the y-axis. So everything is in terms of y. 0 to 1. Big radius, small radius, pi. Big radius square, small radius square. Question is, what is big radius? What is the small radius? So this is extra distance we are adding. X in terms of this is x is negative 1 and 0. So there is an extra 1 in both ways. Now this is a line y equal to x. We are doing everything in terms of y. So this is y. This is a y equal to square x square. So we are doing in terms of, so this is square root y. So I'm bringing my work again back here to check you. We are doing everything in terms of y, square root y plus 1, y plus 1. Same, big R, small r. Evaluate, calculator will give you 0.5 pi. Sometimes we have to set up the integral into two pieces. So let's take a look at that example here. X square plus 1. This is the x square. Y equal to 0 is a x-axis. X equal to 0 is a y-axis. X equal to 1 is this. So we have this region. This region revolving about the y-axis, which means the shape would look like this. So how do we show the setup? So we have two choices. We can see here up to here, 0 to 1 is a solid disk. So disk method for 0 to 1. 1 to 2 is washer method because we have to scoop out this piece. Pause the video for a minute and understand the setup. We have to split into two. This is a disk solid. Here is a washer. So how do we set up? You have two different options. You can do the split between 0 to 1 and 1 square pi dy plus pi 1 to 2. Now you have to big radius minus 1. So that would be, let me show the setup here. That's the setup is here. 1 square is a big radius. Small radius is square root of y minus 1 because this is a y is equal to x square plus 1. We want to solve for x, so that is square root. And you will get the answer. Now, sometimes students are doing it as they find the whole big cylinder, which is you can do it 0 to 2 disk, and you can scoop out from 1 to 2 the bowl, which is also correct. You get the correct answer, and this is the answer. So I hope you have at this time clear idea about the disk method, washer method, rotation along the x-axis, rotation along the y-axis, rotation along the different lines, which are not the axis, but the different lines. Thank you for watching.